Hello friends, in the previous video, we completed the moment of inertia for a L section. Now, in this video, we have another problem based on T section. See, the problem is given, determine the moment of inertia of a section shown in figure. See, the T section is given. You can see this diagram. This vertical wave, this distance is 20. The height of this wave is given, that is 200 mm. This one is a flange. You can see the horizontal rectangle. The distance is 200 mm. This vertical distance, that is 20. So here you have to calculate the moment of inertia of a section about horizontal centroidal axis. So you have to draw this diagram very carefully. This distance is given 20, the height is given 200. So you can divide this diagram into two parts. See, you can divide this T section into two parts. Here we have to just calculate only horizontal centroidal axis. So as previous, we have to divide the figure into two parts. See, this one is the given section. They have taken, this one is a first rectangle. This one is a first rectangle. The height is 200 mm, or you can see the depth is 200 mm, and the base is 20. Here, this one is the second thing, second rectangle. The base is 200. The height is, or you can say the depth is 20. See, in this diagram, just we have to take x-axis, that is the baseline is the x-axis. And y-axis, you can consider y-axis in the center of this diagram, because diagram is symmetrical about y-axis, or you can see the diagram is symmetrical about the center line of this, vertical center line of this diagram. Or you can consider this axis is also y-axis, according to your choice. But here we have to calculate only ix. So for this one will be the diagram. Part 1, this is the part 2. See, in this diagram, you have to consider x bar and y bar. For this diagram, again, you have to consider x bar and y bar. For first diagram, you have to calculate x1 and x2, x1 and y1. For second diagram, you have to calculate x2 and y2. See, diagram is symmetrical about y-axis, so the x bar will be 0. See, the important thing, if the diagram is symmetrical about any axis, if symmetrical about y-axis, then x bar will be 0. If symmetrical about x-axis, then y bar will be 0. So here, not need to calculate x1 and x2. So here we are just calculating y1 and y2. See, this one is the y1 distance. See here, the cursor location. See the cursor location. The distance from base, that is y1. Here, distance from base, that is y2. Already you studied in the engineering mechanics how to calculate y1 and y2. So here the first area, that is 20 into 200. The second area, that is 200 into 20. So here we have taken the value of A1 and A2. The formula for rectangle B into D is base into depth, base into depth. So the answer will be 20 into 200 is equal to 4000 mm square. A2 is equal to 200 into 20, 4000 mm square. So according to the formulas, Y1 will be total height, or you can say total depth divided by 2. So 200 divided by 2, that is 100. And here for Y2 distance, 200 plus is 20 by 2. So the answer will be 210 mm. Already you know how to calculate Y1 and Y2. So I'm not giving that much time to explain how to calculate Y1 and Y2. You all are aware with how to calculate Y1, Y2, X1, X2. So here, you know X bar will be 0 because diagram is symmetrical about Y axis that we considered the center line, vertical center line of the diagram. So here just we have to calculate Y bar only. So for Y bar, we have formula A1 Y1 plus A2 Y2 upon summation of entire area, that is A1 plus A2. So here we have the value of A1, we have the value of Y1, we have the value of A2 Y2. You have to just put all the values in the formula. You have to put all the values in the calculator, you will get the answer. So here area 1, that is 4000, Y1 that is 100, A2 that is 4000, Y2 that is 210, and summation of the entire area, that is A1 plus A2 is equal to 8000. So the answer will be 155 mm. You can see the Y bar. This dotted line shows you Y bar. See, this is the Y bar. Distance from base, because we considered baseline as a horizontal axis. So the horizontal axis, from horizontal axis to this dotted line, the perpendicular distance between baseline and the horizontal centroidal axis of the diagram, that is Y bar, 155 mm. Now we have to calculate moment of inertia about x axis. Now this one will be, see the cursor position. Cursor position is very important. This one is the centroidal point, centroid point. The horizontal dotted line passing through the axis, that is x axis. Vertical line passing through the centroid point, that is y axis. But here just we have to calculate only ix, so we are considering horizontal only. So the formula will be ix is equal to ixx1 plus ixx2, means moment of inertia of a first rectangle area plus moment of inertia of second rectangular area. See, so ixx is equal to ixx plus ixx2. We know that ixx1 is equal to ig1 plus a1 h1 square. See, this formula is as per the parallel axis theorem, because we know the formula of ig1, we know the formula of ig2, but we have to calculate ixx1 about centroidal axis xx. So here ig1 plus a1 h1 square plus ig2 plus a2 h2 square, because formula for ixx1 is equal to ig1 plus a1 h1 square plus ig2 plus a2 h2 square, because this is the cursor location. You can see the cursor location. See the difference between centroid point of the first rectangle and centroidal axis of a diagram. This is the difference between them. You can see the cursor location. See here, you can see the difference between centroid point of the second rectangle and centroidal axis. See, this one is. So here, H1 is the difference between them, and here H2 is the distance between second rectangle centroid point and the centroidal axis of the entire diagram. So here H1 and H2 distances are very important. That already I explained in the previous problem. Here you can see very clearly H1 and H2. So again, we know that Ig of rectangle area, that is B into D cube by 12 plus A1 H1 square. So while calculating H1, Y bar minus Y1, you will get H1. Y bar is 155 mm and Y1 is 100 mm. So here you will get 155 minus 100. The answer will be 55. Similarly, for H2, the total distance Y2 that you have, Y2 minus Y bar, you will get distance of H2. Here you have distance of H2. Once you will put all the values in the formula, you will get answer 33.66 into 10 raised to 6 mm raised to 4. So again, I am explaining you. The first thing, this is T section. The diagram is symmetrical about vertical center line. So X bar will be 0. Just here you have to calculate horizontal centroidal axis. So we have to calculate A1, A2, Y1, Y2, Y bar. After that, you have to calculate H1, H2. Similarly, you know that you have to divide the given diagram into two parts. This one is the first part, this one is the second part. You can see in this diagram, the T section is divided into first rectangle and second rectangle. For first rectangle, we have taken area 1. For second rectangle, we have taken area 2. Similarly, for first rectangle, we have taken Y1. For the second rectangle, we have taken Y2. We have taken base as a horizontal axis, and after that we have taken this dotted line as a XX centroidal axis line, and accordingly we have calculated the H1 and H2 distance. See, I already told you, while taking the distance for XX, you have to consider Y bar and Y1, Y bar and Y2. The larger value you have to take first. See here, Y bar value is higher than Y1, so Y bar minus Y1. Here, Y bar value is less than Y2, so we have taken Y2 minus Y bar. You will get the value of H1 and H2. Whenever you will put the values in formula, you will get answers. So here the answer is 33.66 into 10 raised to 6. See, now I have taken T section. In the next video, we will see the another lamina, the another section. Thank you very much.